Assalamu alaikum. Today we will look into the exercises regarding the Z-transform. We will go into some details in the steps of solving those exercises. For the first one, we have the sequence 5 times 2 to the power n multiplied by u of n minus 10. So we have a shift by 10 samples here, and we have this constant. So the first step, as we learned before, in applying or solving for the Z-transform is to use the definition of the Z-transform. The definition of the Z-transform is, as we saw earlier, it is the summation from n equals minus infinity so this should be minus negative infinity to infinity x of n times z to the power minus n. Okay, so plug x of n here, so here we get it. The constant goes outside the summation. Now we use the property of the step function. Okay, so for this case, if we write the definition again for the step function, it is very straightforward, but let us write it down. So u of n equals 1 when n is greater than or equal 0, 0 otherwise. So u of n minus 10, let's write it down below it, equals 1 when n minus 10 is greater than or equal 0, 0 when n minus 10 is less than 0. So this leads to that it is 1 when n is greater than 10 and 0 when n is less than 10. So we use this definition here in the summation. So the samples less than 10 are zeroed out, so we start the counter from n equals 10. Okay, and we can combine the 2 to the power n with the z to the power minus n into a single term here. So this term, as we learned, we can substitute for it by y, right? But before that, we see that we have a problem here, that the counter should start from 0, not 10. So we can use the infinite geometric series definition and formula. So we need to account for the missing terms. Okay, so what we can say is that, okay, let's say this is y, and let's neglect the constant 5 now for now. Can say that, okay, the this series that we have, let's write it down in a clean way. So from 10 to infinity y to the power n equals what? Equals the infinite series starting from 0, right, minus the first 9 terms, right? So here counter goes from 0 to 9, right? Okay, so this is infinite geometric series, this is a finite geometric series, so we put them in their full form here, and simply we use their formulas. So this is the formula for the infinite geometric series, right? So it's 5, it's constant, it's 1 over 1 minus y. Y in this case is 2 times z to the power minus 1. Okay, so this is infinite geometric series, and this is finite geometric series. So we just use the okay, let's write it here again for easy recollection for it. So this should be 5 times 1 over 1 minus y, right? And this should be minus 5 over 1 minus, it's the same denominator, 1 minus y, but the numerator is y to the power n plus 1. N is what? N is 9, so it would be 10, right? So when you plug in the correct values of y and n, you arrive at this big expression. With some algebra, you can simplify it into this form.